Hello dear students, welcome you all. So in this lecture, I am going to discuss about the activity of a radioactive substance. So in the previous lecture, I have discussed about the half-life period, average or mean life of a radioactive substance. I have also discussed about the radioactive decay law, and we have derived the equation that was n is equal to n naught e raised to power minus lambda t. Here lambda is the disintegration constant, and as far as t half-life period is concerned, this is equal to 0.693 upon lambda, and T average is concerned, T average is equal to 1 upon lambda. I have covered all these things in the earlier lectures. Now, in today's lecture, I am going to discuss about the activity of a radioactive substance. So, activity of a radioactive substance is simply defined as the number of disintegrations per unit time. We can say activity is equal to rate of disintegration, or we can say, or number of disintegrations per unit time. So this is defined as the activity of any radioactive substance. How many disintegrations are taking place per unit time? Rate of disintegration basically we are looking at. So activity is rate of disintegration per unit time, or if we take the time as seconds, so I can say that the number of uh, disintegrations per unit. This is the activity of a radioactive substance. This is how we define the activity. So, more disintegrations per unit time means the material is more active. Less disintegrations, less active. So, we know A is equal to, we also know that the rate of the disintegration, that is equal to dN upon dt. So, if I took the value of n from here, then I will have dN upon dt. So, I can calculate ddt of n naught e raised to power minus lambda t. So, it will give me minus lambda into n naught e raised to power minus lambda t. So, if I take it here, I have to take the magnitude activity, otherwise negative sign will be there. So, according to it, then activity becomes lambda n naught e raised to power minus lambda t. So, I can write it lambda into, this is what? This is n. This term is n. So, I can write activity is equal to lambda into n. This is how we can write activity is equal to lambda n in this way. One way of writing the activity, right? Uh, we know very well that half-life period T half equal to 0.693 upon lambda. So, if I took lambda here, then I will get lambda is equal to 0.693 upon T half. So, if I put it here, right, then what I will get? I will get activity is equal to 0.693 upon T half into n. So, what is it? This is the relation that tell us that activity is inversely proportional to T half life period. So, if a substance has short half life period, then obviously activity will be higher, and if the substance has a longer half life period, because if the value of the T is large, A is small, value of T is small, A is large. So this is how activity depend upon the half life period, right? Actually ये जो हम activity discuss कर रहे हैं, in the coming lectures I will take up some numerical problems जहाँ पे ये use होने जा रही है relation. दो relation हमने derive की, A is equal to lambda n and this one, या फिर ये जो रिलेशंस हमने स्टार्टिंग में लिखी हैं, these are also used in the numerical problems. So in coming lectures I will take some numerical problems to make the better understanding of this topic, right? So this is about the activity, right? So once again I am repeating, activity means number of disintegrations per unit time, right? Now I am coming to the units of activity. or radioactivity. So in radioactivity units, different units are used. What they are going to measure? They are basically going to measure the number of disintegration per unit time. So as far as SI unit of radioactivity is concerned, so it is Becquerel. Becquerel. It is named after Henry Becquerel, and one Becquerel means one disintegration per second. So this is the activity of one Becquerel. Right? This is the SI unit, standard unit for the measurement of activity of any radioactive sample. So once again, I am saying one Becquerel means one disintegration per second. There are some other units which are also used in radioactivity, like Rutherford. Rutherford is also a unit that is named after Rutherford, and one Rutherford means 10 raised to power 6 disintegration. So it is a larger unit of activity. 10 raised to power 6 disintegration per second. There is one more unit, that is Curie, right? So Curie is also a unit of activity. 1 Curie is equal to 3.7 into 10 raised to power 10 disintegration per second. Sorry. So these are the different units that are used for the measurement of activity of any radioactive substance. This is the standard unit, and these are two other units. So in these units, the Curie is the largest unit, that is equal to 3.7 into 10 raised to power 10 disintegration per second. This is 10 raised to power 6. This is uh, you know one disintegration per second, right? So sometimes you can be asked in the exam that what is the relation between the one Curie and one Rutherford, one Becquerel and one Rutherford, one Becquerel and one Curie. So you can see from here, and you can drive the relation between them. So we have to remember that there are three units for the measurement of radioactivity or activity of a radioactive substance. Activity means number of disintegration per unit time, right? And standard unit is Becquerel, named after Henry Becquerel. We have Rutherford and Curie units also, right? So these are some things related to the activity. In the coming lecture, I will take up some numerical problems based on these two topics, activity and units of activity, right? So thank you very much.